In this lesson, we are going to learn how to create a scroll-based animation. Because sometimes we want the experience to be part of a classic website. Currently, we have been creating experiences that are just WebGL, alright? It's the canvas that takes the whole viewport and it was just fine. But sometimes this canvas will be part of HTML content and you will want things like when you scroll, the canvas stays behind and the camera moves with the scroll or other interactions like that. So in this lesson, we will learn how to use Three.js as a background of a classic HTML page, which is kind of the case, but you will see that there are some subtle changes to do. We'll make the camera translate to follow the scroll, meaning that when we scroll through the page, the camera will kind of move with the user while he scrolls. You will understand soon. We will discover some tricks to make it more immersive. We will add a parallax animation based on the cursor position. If you don't know yet what's a parallax animation, do not worry, I will explain everything. And we will trigger some animation when arriving at corresponding sections. You will see. So about the setup, very, very simple setup. We have almost nothing. We have a cube at the center here. We don't have the orbit controls. All right, you can try to drag and drop. You will see that it's not going to move the camera because we want to have control over the camera. We don't want the user to move the camera however he wants. We want to translate the camera, add a parallax to the camera and things like that. So it's just a camera facing currently the cube, which is why we see a square, by the way. We have that UI with just a color. We could have get rid of this one actually, but let's keep it just to update it and keep using that UI. And as you can see, we have some HTML content. Actually, we have more content below, but if you try to scroll, you will see that you can't because the scroll is currently stuck. We will fix that too. All right, so let's fix the scroll actually. The idea is that in our code, if you check on the style.css file in the src folder, we added at the beginning of the course this code. This code was to prevent the user from scrolling because initially we had just WebGL on our page and we didn't want the user to be able to scroll. So we deactivated it. I could have removed from the template, but I think it's better to really start from what we had before. So the solution to get the scroll back is simply to remove those lines of code. So I'm just going to comment them. And as you can see now, we can scroll. By the way, the canvas is currently always behind, the view behind, in front of the user, in front of the viewport, because we used fixed. All right. If it would have been different, like, I don't know, absolute, and we scroll, as you can see, the canvas stays up. So it's up to you and the website you're trying to build. But if you put fixed, when you scroll, the canvas stays in front of the viewport in a way. Let's move on. As you can see, when you scroll, you get this weird white kind of margin at the bottom. Be careful, not every user will have this. All right, it depends on the OS you are using. It depends on the browser you are using. So you might not see it, but some users will. Some users using your website. So we need to fix that. The idea is that currently our WebGL background is black, but the page background is white. That's all. So we need a way to fix that. We could have put the same color as the WebGL for the page. It would have fixed it, but I want to show you something else. We are going to make the clear color transparent on the WebGL, meaning that instead of having this like uniform color on the WebGL, when we do renders, we'll make it transparent so that we can see what's behind, which at first will be white. And we can do that quite easily. If you check on your code, on the 3 WebGL renderer, so on the JS, obviously not on the CSS, it's where we created our WebGL renderer. And we are just going to add alpha true. And that's all, just alpha true. And as you can see, it already fixed the issue. Kind of, we need to put back the dark color, but that's it. You can see through your canvas. Unless you have some objects that are kind of blocking the view, you will see what's behind. So if you have HTML behind, images behind, other canvases, that would be weird, but anyway, you would see what's behind. That's cool. By the way, yes, by default, the alpha is 0. You can change that. If you check on the 3JS journey 3JS documentation for the WebGL renderer, so this one, you will see that you can do set clear color and set alpha. When you do the set clear color, you can provide a color, which we already did, but you can also provide an alpha. And if you put alpha to 0, well, actually the default one is 0, but you can put an alpha like 0.5 or 1 or whatever. If you just want to change this alpha without changing the color, you can also call the set clear alpha. All right, so if I do renderer, don't do it. Set clear alpha to 1. As you can see, even if my WebGL has a transparent background, I'm seeing with alpha true, I'm seeing something. And if I put like 0.5, well, it's 0.5 alpha. And if I put 0, which is the default, we don't see anything. All right, we are going to let it at default because the default one is fine with us. Okay, cool. So let's move on. It's great to see the back, but now we can change the back directly on the CSS. And to do that, we need to target, well, the HTML, why not? HTML, and put the same background as before, which is #1E1A20, like that, which is some kind of very dark red, brown, something like that. And now, as you can see, we can scroll, and we don't see this white margin at the bottom or at the top when the elastic thing occurs. So that's great. It's working really nicely. Perfect. Let's move on. And let's add some objects, because currently we have our cube. That's great, but we need to add some cool objects to our project. We are going to use 3JS primitives, all right? Because currently that's what we know how to use. But later in the course, you will see that you will learn how to import models. So you will be able to create your own models in Blender or the 3D software and import them to illustrate your website, all right? But we don't know yet how to do that. So let's add 3JS primitives. Just like we have a cube, we are going to add other primitives. By the way, the following code will be a bit redundant, but don't hesitate to use arrays or other code structuring solution if you have more sections. All right, we have only 3 sections, so we're going to do like object 1, object 2, object 3, or something like that, but you can totally use arrays. We're not doing more complex to keep things as simple as possible. So let's go back to our JavaScript. Let's get to our cube, this one, and we're going to get rid of the cube. So if you do that, there is no cube, great. And we're going to add some objects. We're going to create them, so we are going to create 3 of them. So mesh1 equal new 3.mesh, and we are going to create the geometry and the material right inside of it. No need to create too many variables. 3 dots, we start with a torus geometry. Like that. Let's use my parameters so that we have no surprise, but if you want, you can try different parameters to get a bigger torus or thicker or thinner or whatever. And we are going to use the mesh basic material to start with, but we are going to change that a bit later. Basic material. And you can add a color. Yeah, it's a red color, why not? We're going to change that too, but still we want to see this one. Okay, cool, that's one. I didn't add it to the scene yet. Let's not forget that. We create a cone. So you duplicate the first one, you change the name to mesh2. And for the cone, here are the parameters. Here again, I simply use the one I tested already. But if you want to try other parameters, please do. And the final one is going to be the torus, but the torus not geometry. And we are going to use 0.8, 0.35, 100 and 16, like that. All right, cool. We use the same material for all 3 of them, and we can now add them to the scene. By the way, maybe I already told you that, but you can add multiple objects like that, mesh 2 and mesh 3. Let's see what we get. All right, it looks weird. I know, do not worry, we are going to do some work on that. Still, it's working. You're supposed to see your objects on the scene. Let's move on. First, let's talk about the materials. We put the mesh basic material just to be able to see something, but we need to improve that. We're going to create some aesthetic website. You will see a bit later. So let's try to make something that looks good. For the material, let's create the base material, which is going to be the mesh toon material. If you remember from the material lesson, it's this one where you have this kind of shading, just like in toons. It looks great. You will see that it will fit what we want to create later. So let's go. We're going to create one material and use it for all three meshes because it's just better for performances. Const material, you could have called it maybe mesh material, but you will see we will not have many materials in this project, so material is fine. 3, and we use mesh toon material, and we can provide a color. And if you remember, we have already that GUI with this color, and it's this one, all right? That GUI is instantiated, it's this one, and we can use the parameters material color. So let's go. Color, parameters, material, I think it's, yeah, material color. Was that it? Yeah, that was it. Then we use this material for the first mesh, the second mesh, and the third mesh. And let's add some comments. Meshes and material. Those are, you can skip those. It's up to you. I like to add comments. All right, that's great. Not really. If you check closely, you will see that there is something there. Those objects are actually fully black in a almost black background. If you can't see it, do not worry, we are going to fix that anyway. What is happening? You might know what is happening. The mesh toon material is one of those 3GS materials that appear only when there is light, all right? It's light-based material. If it's fully dark, you can't see anything. That's the idea. So we need to add one light. So let's go. Right after it, actually it's not that important. The order is not that important as long as it's after the scene. We're going to add some lights. Actually, there will be only one light. And we're going to call this one directional light. You can call it, I don't know, like the sun or whatever. It's not that important. It's a bit more abstract anyway. Directional light, and it's going to be this one. And we can provide some parameters, which are the color. So it's going to be a fully white light. You can maybe tweak this one too, so it's up to you. Maybe you can add it to that GUI. We are going to move it. So position set 110, which is somewhere like compared to the camera. If I'm the camera, it's like on my right, slightly above. So it's gonna illuminate like that, seen from my side. I hope it's not inverted. And we add it to the scene with add directional light, like that. Finger crossed, and it's working, that's great. So still we have this blob thing because we have all our objects at the same position, but now we can see them, that's great. Let's move on. If we change our tweaker, it's not working. Yes, we are using the parameter, so the parameters material color on the material. Then we create this tweaker. The tweaker was already there, but when we change the tweak value, it doesn't update the material. We can do that quite easily, as we already did before, so it's kind to do what we already did. On change, so we listen to the on change event on the tweaker. If this happens, we update the material by doing material color set, and we provide that color that has just changed. Material color. This is just a bonus for this lesson. And now, as you can see, we can change the color. I'm going to keep the default one because I like the final result, but you can change it to whatever color you want. Okay, so this gradient is a good start, but if you check the documentation, you will see that here we have more shades. By that, I mean, you can see 3 different states, like in the light, in the kind of shade, but not really, and in the full shade, all right? 3 colors. How can we do that? Currently, we have only 2 colors, in the light or in the shade. To fix that, we are going to provide a texture. So it's a gradient texture, and you can find it. Let me show you. Yes, it's the right folder in the static textures gradient folder. And I gave you 2 different textures. So it's not working. I don't know why. Okay, here it is. Be careful when you try to preview this picture, you might have some surprise. So here's one with the number 3. There is 3 different colors, and it's actually 3 pixels. All right, maybe it's big, as you can see like that, but there is only 3 pixels in that image. And another one, so it's the, I really can't see it, maybe it's like in the middle right here. But if I resize, as you can see, there is 5 different shades. We're going to use the 3, but I provided you the 5, just in case you prefer the result with the 5, it's up to you. So let's go. We need to load it and provide it in order to have more shades. This is how the mesh toon material works. This one is using 3 different pixels. That's why we get 3 different colors. By default, it's just shade or light. So we are going to do the same as this example and provide the texture. So we are going to go, let me see. Yeah, right before the material. And we're going to create a texture comment. Why not? Const texture loader, we need to load the texture. Usually I put the loaders at the beginning of the code, but this is the only texture we are going to load, so I will put it there. New 3 texture loader, like that. And then we can load the texture, so we create a variable, gradient texture, equal texture loader, load, and then you provide the path to load the textures, and as always, it's without the static part. All right, so textures, gradients, and we're going to use the 3.jpg. Yeah, we're not going to use the 5. It's up to you if you want to test with the 5. All right, that's cool. Now we can use it, I guess. Let me just see if there is no error. Okay, everything seems fine. Just update. We're not using it yet. Just update, save. And check for potential errors. Pause the video if you have errors. Now we can provide it to the mesh toon material. I'm going to add some line breaks. And we are going to provide the gradient map, and it's the gradient texture. All right, that's the property to provide another map, gradient map to the mesh toon material. And it looks weird. That's not what we expected. There is something happening. I told you that the gradient is this very, very, very small image of 3 pixels. When the mesh toon material is receiving colors, light, he will try to pick one of those from the left to the right. So if it's in the light, he will take this. And if there is not much light there, and if there is no light there, and there are some in-betweens. By default, WebGL will try, WebGL with Three.js, it depends on how it's configured, we are going to change it anyway. We'll try, if you provide, let's say there is that much light, from 0 to 1 there is that much light. It's right between those 2 pixels. And the WebGL will kind of find a mix between this one and this one, which is why we get this full gradient from dark to light, and we don't get this shading effect like that. Okay? So that's not what we wanted. We need to change that. To do that, we need to provide a mag filter different from the default one. So it's on the texture itself. We're going to say, to write gradient texture, mag filter equal, and we are going to use the nearest filter. All right. The nearest filter will take, let me show you again the image, we take the nearest one. By that I mean that if the light intensity is right here between those, well, it will take the closest one, so it fits. If it's there, it will be the white one. If it's there, it's going to be the gray one. Gray, 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 and the dark one, dark, 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 dark. So no gradient, no mix between those. So we save, and as you can see, now we have this shading, and it looks better. Still, we have this blobby, weird stuff, but we have our shading and our material works nice. So let's separate those objects, which are clearly not at their position. The idea is that we have 3 objects and we have 3 sections. We are going to put one object to the right, then one object below to the left, and then one object even more below to the right. And when we will scroll, well, those will, the camera will go down and we will see the objects coming just like the HTML page is coming. That's the idea. But how are we going to place them? There is something very interesting here is that the field of view is vertical. What do I mean by that? In 3GS, the field of view is vertical. So if you check on the camera, let me show you the camera. Where is it? There. We have a field of view of 35 degrees, meaning that here am I. We have a field of view like this. It's the vertical field of view. It's not like that. It's not horizontal. It's the vertical field of view, which might sound a bit weird, but usually it's better. Like it's more handy. And actually, it's going to be very handy in our case. If we put one object, let's say right above, like there, at the edge of what we can see, and one object at the bottom, and then we resize everything, the object will always stay on top and at the bottom. I can show you that. You don't have to do it. If you want to do it, you can, but you can just watch the example I'm going to provide. We're going to use that, and this will position the first mesh on top, right on top. I just put a value that make the object on top. It will hide the second one, and it will put the third object at the bottom. It's the exact same distance. So it's 2 above, and this one is 2 below. What I want to show you, check that, is that when we resize, see, because the field of view is vertical, we always see that angle. The scene doesn't change. When you resize, the scene doesn't change. And as you can see, they stay always at the top and at the bottom. And that's great for us because we will not have to move the object further if the view is, I don't know, like wider or higher or whatever. If the resolution is different, we don't care about that. We just place the object, place one below and place one below. And even if the user resizes, you will get the same result. The object will be at the same distance on the screen and in the scene. Okay, so let's get rid of that. It was just a temporary example. And we are going to move them down. So the first one can stay here. The second one will go down. We'll find the right distance. And the third one will be, we go down twice that distance. Okay. We need to provide some information. So I'm going to create a variable, object distance. So this will be the distance between each object. For now, we don't really need to put that in a variable, but you will see that it will get handy later. So let's put it in a variable. So it's objects with an S distance. And we put a random value, let's say 2, where we'll be able to change this one later. We're not currently using that variable. What we are going to do now is move the first one, so the mesh 1 position.y of that distance. So object distance multiplied by 0. Yes, it's kind of useless to do that, but once we do it for the others, so the 2 and the third, and we multiply by 1 and we multiply by 2. The idea is the first one will be there. The second one is supposed to be down from the distance we just provided, and the third one will be down like twice this distance. And obviously you can add more sections. But I got something wrong there, is that they are going up, all right? We need the objects to go down. Just like the content, the HTML content is down, it's below, where we need to put those objects down. So we do minus, minus, minus. All right, and now the objects are below. We have the torus there, we have the cone there, and supposedly we have the torus knot below. And if we resize, they stay where they are relatively to the viewport. So that's cool, that's cool. Yes, you can remove this one. I will keep it for the sake of the lesson, but multiply by 0, it's 0 anyway. So that's great, but when we arrive on the website, we don't want to see the objects of the next session. So we can simply increase this one, 3. It's kind of hidden, but trust me, you better put a bit more, let's say 4. All right, you can put more, you can put less, you can change this one later if you want, but a good number is 4. So the torus knot is there, the cone is over there, we can't see it, even if I move down, because the camera is not moving, the HTML is moving, but not the camera, and the torus knot is even more below. Okay, cool. We are going somewhere. Let's add some life to our scene, because right now we could have created, I don't know, a render on Blender or something like that and put it behind, and we would have get the same result because nothing is moving. What we are going to do is add some life by rotating the objects. First, we are going to save them somewhere. After adding them to the scene, we're going to do const section meshes equal, and we're going to create an array with those 3 meshes. Again, there are so many ways to do that, to structure your code. I just try to keep everything as simple as possible, even for beginners. That's why we are doing in an array after and things like that. All right, so currently all our meshes are inside that array. What we are going to do now in the tick function, so scroll down to the tick function, and it's going to be before doing the render, we are going to animate those objects. So animate meshes. We loop through those meshes. This way, if you add more meshes, well, it will work. And we do const mesh of section meshes. So we are looping through this array. And we are going to rotate them in 2 axes. You don't need to rotate in 3 axes, because in the way, if you rotate on 2 axes, your object can go in every directions. So mesh rotation x equal, and we're going to use the elapsed time so that it's based on the time and we have no surprise with different screen frequencies. We will have some issues with screen frequencies later, but for now we just use the time, the elapsed time. So we can do one test like this. As you can see, it's rotating. That's cool. Let's reduce the speed. Don't make your objects move too fast. All right. Remember that it's a classic HTML website with classic content. Your users will want to be able to click on buttons, to scroll, to enjoy the text and things like that. So make things move not too fast. Okay. So X and Y. And this one, we just slightly change the speed so that it goes through different position. Anyway, don't put the same, otherwise you get always the same rotation. Okay, that's cool. They are rotating. At least this one is rotating, but because we are looping through every meshes, all of them are rotating. Now let's take care of this camera, because we are doing stuff that we can't even see. I'm talking about the objects below. We want to move the camera with the scroll. But first, we need to get that scroll value. We want to know when the user scrolls and how much this user scrolls in order to move the camera down. So let's go. We can put the code, camera scroll. We can put the code, let's say, right before the animate. Should be fine. So let's create a scroll section, and we are going to save the current scroll value. To get the current scroll value, you can do window.scroll_y, and I can show it to you. I didn't save yet. I can show it to you. Like if I scroll a little and I do window scroll y, as you can see, we get how many pixels we just scrolled. So if I scroll more, I call it again, we get more. Okay, cool. So we can already start by saving it. It's just in case the user where the JavaScript is being triggered, starts when the user already scrolled. All right, it can happen. So from the beginning, we get this value. Next, we need to update that value when the user is scrolling. To do that, we can listen to an event named scroll on the window. So window add event listener. We listen to the scroll event and we trigger that callback function there. Log user is scrolling. We can do something like that. And when I scroll, as you can see, we get a lot of events being triggered. So it's working. That's great. By the way, the elastic thingy is not triggering scroll. I guess on every browser, just so you know. So now we can update it. So it's exactly the same line of code. We do scroll y equal window scroll y. Make sure you're using a let because you are updating this value. And we can simply log it to check that it's working. And as you can see, when I scroll, so if I start from the beginning, 0, and then it goes up, 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 up. That's interesting. So in a way, we are going down, but the scroll value is going up. Let's keep those in mind. And those are pixels. So if I scroll, let's say the length of a viewport, I go to the next section, we get something like this value. Obviously, you have a different value if you have a different viewport. And it's the size, yes, that's kind of the size of the viewport. So it makes sense. Cool, let's move on. Now in the tick function, you can remove the console log. In the tick function, we are going to update the camera accordingly to that value. So we can do it, let's say right here, and we are going to do animate camera. And we're going to do something very simple just to see what we get if we do that. We're going to do camera. So it's our camera, perspective camera, position.y, because we want to move on the y axis, equal, and we use the scroll y variable that we just created. All right, move to the top, because we are going to have some bad surprises. Move to the top, save, and let's see what we get. If I scroll, whoop, okay, I just slightly scrolled, and as you can see, oh, everything is gone. If you scroll very slowly, like slightly, okay, you see, we have two issues. I'm barely moving, and the camera is jumping in the wrong direction and way too fast. Those are the two issues we have. So first, let's fix the direction. We want the camera to go down, all right? Our objects are down, our HTML content is down, but the scroll value is going up when we scroll. It's a bit weird, but now that we know that, we can simply negate that value. Now when I scroll down, oh, here's the Taurus knot. It's been a while. Okay, so we are going in the right direction. Be very sensitive with this scroll, because if you scroll too much, well, the camera went way too far. So the direction is fixed. Now we need to fix that sensitivity. The reason is quite simple. If you remember from the scroll Y, I'm going to log it. You don't have to do it, but I'm going to show you there. As you can see, when I scroll, it's how many pixels have been scrolled. All right, that's cool, but we are moving the camera from that. And remember that in Three.js, well, 1 minute can be whatever you want, but our scene is currently going something like 8 units down. So when we do a huge scroll, like 1000, the camera is going 1000 units down, but our scene is just something like 8 units down. So we need to do some mathematics to adapt this value. So let's go. First, we know that each section has exactly the same size as the viewport. All right, this means that when we scroll the distance of one viewport height, the camera should reach the next object. Check my screen. If we scroll, forget about the WebGL behind. If we scroll one section down, we should see the other object. So if I'm here, it should be 0 for the camera position. Forget about what we have in the WebGL. If we scroll down for one section, it should be something like 4. Why 4? Well, because there is 4 units, as you can see here, between our objects. And if I move down even more, it should be 8. All right, it's 4 by 4. That's what we want. We want 0, -4, -8. And we just need to do some math to get that. I won't lie, usually I just tweak the values, tweak the formula, and I get the result. But I'm going to explain to you to you anyway. First, we are going to divide the scroll Y by the size 8. Why are we doing that? Let me show you. We divide by the size 8. The size 8, if you remember, is the size of our viewport. We already calculated it a bit before. It was over there. See, it's the window inner height, and we update it when the sizes changes of the viewport. When you do that, okay, that's already much better. Currently, when you scroll of one section, we went down from 1 unit, right? Because we divide the scroll value. You can log it. Let's go down from 1 unit, one section, I mean, and as you can see, we went down from 1 unit because we are dividing by the size of the viewport. So it's almost it. What we need to do now is multiply by the distance between objects, because currently we're going down from -1, so distance of 1, but we need to go 4 by 4. We need to go object distance by object distance. So we multiply by that. And as you can see, now it's working. And we have our objects matching the sections, and our camera is going down at the right speed. That's cool. Okay, let's move on. Yeah, the camera is going, okay, we already said that. That's cool. Currently, all our objects are at the center. We're going to change that very easily. To change that, we're going to move the objects once on the right, once on the left, and once on the right. All right, easy. You can do some calculation like if it's even, it goes there. If it's odd, it goes there. It's up to you. I'm going to keep things really simple and do mesh one position.x equal 2. As you can see, it goes on the right. And the second one I'm going to do, so mesh 2 position equal -2. So position x equal -2. Okay, this one is on the left. And the third one, we do 2 again, like that. Because I want to keep things simple. All right, starting to look like a real website. Let's move on. One cool thing to add, it's a bonus feature, is the parallax. What's a parallax? Parallax is the action of seeing one object through different observation points. Like if you put, I don't know, you put one hand in front of you, the other one right behind, and if you move your head left and right, well, sometimes you will see the one behind, and it will be on the left and on the right, and in a way, you kind of feel the depth of things because of that. And actually, your eyes are already doing that all the time. If you watch something with your two eyes open, well, you know the depth of something because your eyes have different point of view. They are seeing things from different positions, and your brain will understand how far things are. So that's the idea. We're not going to do this kind of eyes thing. What we are going to do is to make the camera move with the cursor so that we can see the scene from, well, changing point of views and make the whole thing more immersive and let the user feel the depth. That's the idea. If the camera moves, you can feel the depth and it's going to move with the cursor. So let's go. First, we need the position of the cursor. We can do that right after the scroll part. Why not? We're going to do a cursor section and we're going to create a variable named cursor. You can do that really differently, but let's keep things as simple as possible. We're going to do cursor x equals 0, cursor y equal 0, 2. And when the mouse, the cursor moves, we're going to update those values. So let's go. To do that, we need to listen to a new event on Windows. It's window add event listener. The event is mouse move, so it's when the mouse is moving. Be careful, it's all lowercase. And we trigger that callback function. And we can do the mouse just moved. And as you can see, if I don't move, nothing is happening in the console. And if I move, it's happening. All right, cool. We don't want to do a log. What we want is update those values. And to do that, first we need to provide a value here. Something will be injected into it, as you can see. Oops, I broke everything, my bad. And when we move, as you can see, we get some values. And we can retrieve the position of the cursor by using client X, a client Y, as you can see here. So I can show you client X, so it's an object, client X. And if I'm on the left edge, I have something very close to 0. On the right, something close to 1000. And you will have different values depending on your resolution. That's great. Those are pixels, by the way. Let's keep that in mind again. It's working also with the Y, up and down. So the top will be 0 and at the bottom of the viewport, it will be a higher value, which is weird too. As you can see, when we go down, the value is going up, just like the scroll value. Let's keep this one in mind too. So we can update cursor X and do event.clientX. We're just saving those in the variable we created right before. Client Y, and if you want to make sure that you did it right, you can log the cursor. And if I'm on the top left corner, I have something close to 0 for both. I go down, the Y is going up, the value Y is going up. If I go to the bottom right corner, both values are high. Okay, that's cool. Let's move on. We could use those values to move the camera directly, but as you can see, they are a bit weird. Okay, it's always positive. That's the first thing a bit weird, because we want the camera to be able to go left and right, to go up and down, so positive, negative, and we also want to move at the right, intensity, all right? Currently, if we move the camera from this value, as you can see right here in my console, where the camera will go way too far from the scene and we will lose our objects. So we need to do some work on those values. We are going to update those values to adapt them. First, let's make sure that those values are kind of always the same regardless of the resolution. All right, because right now I will show you the cursor X is going from 0 to almost 1000, but if I have a huge resolution, let's say like that, as you can see, it's going much higher. So this is not good. We want the same experience for every user. To do that, we can divide by sizes width for the client X and by sizes 8 for the client Y. And as you can see, by doing that, it goes from 0 to 1, 0 to 1, regardless of the resolution, 0 to 1. Because we divide that value, that value that went from 0 to how many pixels, by the maximum possible of pixels for the width. So it's perfect. Let's make sure that the Y is working just the same, from 0 to 1. Great. Okay, that's cool. We can move on. We could use that. Oh, by the way, I call those normalized values because they go from 0 to 1, which is not totally accurate, but still kind of. You will see a bit more about normalized values later in the course. Another thing that I like to do, most developers don't do that, but me, I really like to do that, is that I know that my value needs to be as negative as positive. By that I mean what I said a bit earlier, that the camera can go up but also down, and the camera can go left but also right. So on the X and on the Y it can be positive and negative. So what we are going to do, because currently those are going from 0 to 1, we are going to make them go from minus 0.5 to positive 0.5. It could be from minus 1 to positive 1, but I like values that have a 1 unit amplitude. So from minus 0.5 to positive 0.5, it's still a 1 amplitude. So we do minus 0.5, and let's log it again, so only the X to focus on it. If I'm on the far left, I'm at minus 0.5. If I'm near the center, I'm near 0. And if I'm on the right part, I'm at 0.5. And that's a good value. That's the kind of value I like to work with. All right, next part. We're going to use those values to move the camera. So it's in the animate camera part. We can do right below, actually put it right below this one. All right, you will see, because we are going to have some issues. We're going to create a variable. It will look totally useless, but trust me, it will get handy later. And we will do parallax x. So be careful, there's 2x because parallax x equal cursor.x. What did I do? Okay, that's better. And we do the same for the parallax y equal cursor.y. Okay, so we just put those values inside variables, and now we are going to use those variables on the camera. So camera position.x equal parallax x. As I said earlier, having those variables we get handy soon. And we do the same here. So position y equal parallax y. Be careful, this is not good. We save. Never mind, I did mistake. Parallax, yeah, it's not. It's 1R and 2L. What? So let's move the cursor. Okay, it seems to be working. Kind of. It feels weird. We have two issues. It's moving, that's great. If I move left, it moves left, up, down. That's cool. The first issue, don't scroll. The first issue is that the X and Y are not sync. By that I mean that when you move left, as you can see, the object is going right. If I move right, the object is going on the opposite direction. But when I move up, well, the object is following the cursor, and when I move down, the object is following the cursor. So they are async. They are not doing the same thing. So we need to fix that. And the other issue, check that. I scroll. The scroll is gone. My camera is not going down. So let's fix that. First, we're going to fix that X and Y thing because it's really easy to fix. It is that we just need to negate one of those. If I negate the parallax Y, as you can see, now it's working and it feels much better. This is a classic issue made by beginners. You just need to invert it. The reason is that when going down, the cursor Y was going up, okay? When the cursor, remember the value when we put the cursor at the top, it was 0. And when we moved down, the value was going up. That's great, but we want the opposite for the camera. So that's why we are just negating, I don't know if we can say that, the value like that. And now it's working. It looks like we are moving the camera, and because we are moving the camera, well, objects are going at the opposite directions, and it feels better. But now for the scroll, so the second issue. The problem is that we are moving the camera, we are on the X and on the Y values. But we already tried, we already changed the camera position on the Y to do the scroll. So we have an issue. We have different ways of handling that. What we are going to do is put the camera inside a group. All right, we already used the group before. You put inside a group, you will get the exact same result, but we are going to apply the parallax on the group. So imagine that you put your camera on a box, we move with the parallax, with the cursor like that, but then the camera inside the group will move with the scroll like that. So if we scroll a bit, well, the camera will go down, and if we move with the parallax, it will do something like that. So we still have both animations working. That's kind of kind of ugly way of doing it. There are other solutions, but I wanted to show you this one, which is easy and totally efficient. So let's go. We move up to the camera part. Before creating the camera, we create the group. So group, we're gonna do const camera group, why not, equal new 3.group. Come on. Like that. A group is just an empty thing. There is nothing inside currently. And we add that group to the scene. Scene, add group, camera group. Then the camera, we don't add it to the scene, we add the camera to the group. So here we need to change scene by camera group, like that. We save. Currently we get the exact same results, okay? The camera is inside the group, we are moving the camera with the parallax, but the group is not moving yet, okay? It's just a group at the middle of the scene and the camera is inside it. But now, instead of moving the camera for the parallax, we can move the group itself. So here, not here, we still move the camera with the scroll, but for the parallax we do camera group position X and position Y. The parallax is still working because the camera is inside the group and we are moving the group for the parallax, but now the scroll is working too because the camera is moving inside the group. All right, cool. Next, it's working great. We did good progress, but let's go even further. Currently, as you can see, when we move the cursor, well, it's going quite instantly to the destination, which is good, but not very realistic. If you try to move, let's say, a camera, like a movie set camera, it's heavy, it's attached to someone that has to move, it has to activate his muscle and everything. You can't move like a robot. Even a robot, we have some friction, there is the weight of the thing, etc. So to get something more realistic, we are going to make sure that things doesn't move as fast. We call this easing. I like to call this one easing, but some people use smoothing because it gets smoother in the animation, or lerping because the actual formula is a lerp formula, as you will see. So we are going to make it move like with an easing, move smoothly. Let's say smoothly. Yes, I have trouble saying smoothly. On each frame, instead of moving, I will try to explain to you as a text and then I will do a drawing. On each frame, instead of moving the camera straight to the target, which is what we are currently doing, we are going to move the camera, let's say a tenth closer to the destination. So a small portion toward the destination. So if the camera is supposed to be, I don't know, like 10 centimeters on the right, let's say it's my head. I'm supposed my cursor moved, so the camera is supposed to be there. I'm not going to move straight there. I'm going to move a tenth closer to that destination. And on the next frame, I'm going to move a tenth closer. And on the next frame, a tenth closer and closer and closer and closer. And always the same portion, a tenth. It can be other portions, but we are going to focus on 1/10. You will see the result. So we get closer, a tenth, a tenth, a tenth, a tenth. And as you can see, the closer we are, the slower it gets. Let me show you with some drawings. Let's focus on one axis. So here's one axis. All right, that's enough. Let's say we have 0 here. Let's say we have, I don't know, like 1, and let's say 2, and actually the unit is not that important. Our camera will start, let's say, at 0, so it's right here. And our camera, because we move the cursor, we want the camera to go to, I don't know, like 2, right here. Let's say that the destination is right here. Currently, we are moving the camera straight to that position. So on one frame, paf, we are here, which is not very realistic. What we are going to do now is move the camera a tenth closer toward that destination. So tenth would be, I don't know, something like over there. Okay, so right now we are here. On the next frame, we are going to move toward the destination a tenth again. So we are right here and we move toward it a tenth. So we get something over here. It's going to be a bit long, but follow me, you will understand. On the next frame, we move toward it. So it was over there, a tenth. So it's over there. And we go over there. Oh, yeah, it's working. Over there. On the next frame, let's make it better. Okay, it's enough. So we are over here and we move a tenth toward the destination. Okay, one more time. On the next frame, we still need to go, I'm going to put the same stroke, so this one. We still need to go to that same direction, but we are going to move a tenth over that direction. And as you can see, it's going slower and slower and slower, because a tenth, initially it was, let's use that value, it was that distance. I mean, that distance divided by 10. But then it was much less. It was, I mean, not much less, but a bit less. It was that distance, and then that distance, and then that distance, because we are already getting closer, and we move a tenth closer. And as you can see, we never reaches that destination, all right? The destination is right here. I mean, let's use the right value, so it's purple. The destination is right here, it's right here, it's right here, it's right here, it's right here. We never reaches that destination. It actually takes a lot of time to get even closer. And if we would have said, I don't know, it's not a tenth, it's half of it, where we would have been there. The next part, the next frame, we would have been there, and then there, and then there, and then there. Yes, we are getting closer much faster, but we are never reaches that destination. And we are going closer slower, right? More time spent, the slower. Okay, cool. That's the idea. Let's get back to our code and apply this. So what we're going to do is, as you can see, we are adding to the current position. So on each frame, we're adding to the current position. So first, it's not equal. It's going to be plus equal. Okay, let's get everything on set. Okay. Then we need to calculate that, we use this one, that distance. Okay. So it was the distance from the current position toward the destination. This one. Okay. So we need the current position from the destination. To do that, we need to do, well, the current position. The destination minus the current position. Let's go. So it's going to be the destination, that's the target, parallax X and parallax Y, minus the current position. So it's going to be camera group. Don't forget that it's on the group, not on the camera. Position for the first one is going to be X. I said the first one X and the second one Y. Like that. Okay, cool. But currently, we are moving from that value. I mean, we calculated that delta value, so the offset between the current position and the destination, and we are jumping straight to it. Okay, that's not what we want. We want to go there, but only a tenth of that distance. So we multiply by 0.1, or you can divide by 10. It's up to you. It's the same thing. Let's see the result and see how smooth the value is. Not smooth enough, where we can just change the value to, I don't know, something even smaller. And as you can see, it's super smooth. And if you want it to be faster, still have the smoothing, but faster, let's say 0.2. As you can see, we still have some kind of easing, but very small and slight easing, and it's working just fine. Okay, great. Let's keep the 0.1 value, but we have an issue. If you test the experience on a high frequency screen, which might be the case for some of you, the think function will be called more often. All right, your screen is as high frequency, so the experience will update more often. Like in 1 second, it will update more often. Then this formula will be applied more often. So on high frequency screens, the animation will be faster, which is not what we want. We want the same thing for every users, regardless of their speed. We need to do some tricks there. I mean, not speed, their frequency, screen frequency. What we need first is to know how much time was spent since the last frame. All right? And we will use that in that formula. We need to calculate the delta time. It's the time between now and the previous frame. So let's go. First, we have the clock there. We are using the 3GS clock. We're going to create a variable named previous time and set it to 0. Then in the tick function, right after setting the elapsed time, I mean getting the elapsed time from the clock, we're going to do const delta time. So that's what we want to calculate. And it's the current time, so it's the elapsed time, minus the time right before. All right, we are comparing the current time with the time right before. So if right now we are at 10 seconds and right before we were at 9 seconds, well, there is a 1 second offset between those. So that's kind of the idea. But if we do that, we also need to update the previous time for the next frame. So to do that, we do previous time equal, well, the current time. You can log the delta. If you don't follow this formula, you don't understand totally this formula, do not worry, you can just check the delta time. And as you can see, we get this kind of value. You might have a different value if you have a different screen frequency. I have kind of the default setup, which is 60 frames per second. But if you have a high-end PC with a higher frequency, well, this value will be smaller. Smaller because you have more frame in 1 second, so there is less time between each frame. Cool. So we can remove the console log because before making our computer bug. And we are going to use that delta time right here. We use the time between those, but it seems all broken. It's not. Thing is, it's just moving super slowly because the delta time is in seconds. The value will be very small. As you can see a bit earlier, for 60 frames per second, which is my case, it was around 0.016. So it's super small. So we have already something small and we multiply it by something even more small. So to fix that, we can simply make it faster by doing, I don't know, something like 5. As you can see, it's back. You probably get the exact same result, but thing is, now if you test this on different screens frequencies, you will have the same speed. That's the idea. We are basing our animation on the frame rate and the frame rate speed. I mean, in the frame rate, the frequency of the screen. Okay, cool. Next, Yeah, by the way, the intensity of the parallax is a bit too high, so it was useful until now, but it's a bit too much. As I said earlier, try not to make things move too much. It's bad for your user. Unless it's a video game or whatever you're creating, let's keep things a bit slower. Something like that is already more than enough, trust me. Okay, so that's super immersive, it's a great feeling, that's cool. Let's move on. Particles, something I like. A good way to make the experience more immersive and to help the user feel the depth is to add particles, alright? It's not just because it's cool, it will also help the user to feel the depth, because currently the user can only see one object and all these parts are just darkness, you can't see much. We're going to add particles, some will be further away, some will be very close to the camera, and the user will really feel the depth of the WebGL, the experience. It's going to be very simple particles, but obviously you can improve them if you want after the lesson. So yeah, we want to position those particles, well, kind of everywhere. So we are going to create our own buffer geometry like we did in the previous lessons, the particles lesson and the galaxy generator lesson. So let's go. We're going to do that, let's say, yes, right after the meshes. Why not? This is fine, just here. Particles. It's not that important to put it before the light, but why not? First, let's create the geometry. We're going to go a bit fast on this because we already did it in the previous lesson. But you can pause the video and try to create those particles yourself. It's hard, okay? We did it maybe twice, but it's something a bit difficult. So practice it and you will get it. So let's create the geometry. First, we're going to decide how much particles we want. So particles count equal, let's say 200. I think it's going to be more than enough. Then we're going to create a float32 array and we're going to call it positions. Yeah, why not? Plural. Float32 array. If you remember from the previous lessons, it's how you store the positions. And it's going to be the particles count multiplied by 3 because we need 3 values per particle because x, y, and z. Nice. Then we can loop to create those particles. So for let I equal 0, I inferior to particles count, I plus plus. And we are going to fill this array with random values to begin with. So position is going to be I multiplied by 3 plus 0. I know it's useless, but I like to keep this one. And we are going to just put a random value. We're going to change those later. So this is going to be the x position of the particle, then the y position of the particle, and the z position of the particle. Again, if you don't understand this part, just go back to the particles lesson. Then we can create, well, the geometry itself. So const particles geometry equal new 3 buffer geometry. And we provide that array, so the positions to this geometry, by doing particles geometry set attribute, because it's an attribute. For the attribute, the first parameter is the name of the attribute. We don't have a choice, we need to use position. It's how the shaders will use it. And as the second parameter, we need to provide a buffer attribute, so new 3 buffer attribute. And this one, the first parameter, is our float32 array, so this one. And the second parameter is how many values per vertex. We need 3 values, as we said earlier, x, y, z. So in the array, it's going to be x, y, z of the first one, x, y, z of the second one, x, y, z of the third one, and it goes on like this. Okay, you can save, though we have nothing on the screen. You can just make sure that you didn't do any mistake. If you get an error out there, well, fix it first. So this is our geometry. We keep things quite simple. We can create the material. Const particles material equal new 3 points material. And we are going to provide some parameters inside this object. So we need to provide an object. So for the color, let's use the same color as for the material. So parameters material color. Size attenuation, yes, So size attenuation true, so that particles further away are smaller. We get some perspective. And we decide on a size. You can use my size, but obviously you can change all those values as you please. Then we can save, make sure we don't have any error in the console, and then we can create the actual points. So const particles equal new, and we use not a mesh, we need to use points. So 3.points. Parameters are the same as for the mesh. We need to provide the particles geometry and the particles material. We save, still no error, that's good news. We can add it to the scene with scene add particles. And we did a mistake, which is particles geometry, position. Oh, yes, I did a mistake here. It's not particles geometry, it's positions. Okay. You probably saw this one, that's on me. It's the positions array. We don't provide the geometry to the attribute of the geometry. Okay, that's great. Here are our particles. So obviously they are not well positioned, but we are going to fix that quickly. And actually right now. So let's move the particles here and there. First, let's focus on horizontal axis. So it's the X, moving like that, and the Z in the depth. And we can just provide random values. So this one is the X, and this one is the Z, and this one we will do it after. What we are going to do is mathRandom minus 0.5 and mathRandom minus 0.5, so that it's as negative as positive. If you are at the center, you will see that it can be as on the left as on the right, and as further as behind. So this one is a bit different, but I mean, we can't see it, but it's going further and closer to the camera. But it's clearly not enough. The amplitude is currently 1 unit, which looks like something like that. We need to add more, so we're going to put that into parentheses and multiply by 10. And we can do the same for the Z. Multiply by 10. Again, you can change those values to whatever you want. Okay, much better. But currently on the Y, so the vertical axis is going from 0 to 1, so it's only going up. What we need to do now, first, is to make it start slightly above and then randomly go down. So we need to move it slightly above, and we are not going to provide a value like 1, 2, or 3. We're going to move it half the size between each object, because it kind of makes sense. Object distance, multiply by 0.5, and then minus mathRandom, and multiply by, I don't know, let's say 10 to begin with. So currently they are starting, see, a bit above. We don't have any more particles above, so this value is just fine. You can add, sorry, 0.5. I put 0.4. So they are starting a bit above the scene, and they are going down randomly for 10 units. So if you scroll, as you can see, it seems to be working fine. But it stopped there because I put 10. If I put, let's say, 5, you will see that it will stop faster if we do something like that. Instead of just trying to find the right value, we are going to use the object distance. So object distance, and we are going to multiply it by 3. Why 3? Well, it starts a bit over here. So it's going to do 1, 2, 3, right here. And actually, let's do a quick fix compared to what I have here. We're going to use how many objects we have in the scene, and we can have this with the section meshes. So instead of just putting 3 and changing this value if you have more objects or more section, we can do section meshes dot length. This way, if you have more objects, well, it will go even further. So it's working nicely. So 1, 3, yeah, it's fine. It's fine. Now we have particles spread across the scene, and you can feel the depth, especially when you move the parallax. I mean, when you move the camera like this by moving the cursor. So it's just a small trick, and I just like particles, as you probably already guessed. One small thing to change is that if I change the color to fix is that if I change the color of the material color tweak, well, it do change this one, but it doesn't change the particles, so we can fix that easily. by going there, so the on change, and by updating the particles material color, and do the same thing with set, and I'm going to provide the same value. So when we change this, we send it to the particles too. Okay, they are green, that's cool. But I'm going to keep the first color. Obviously, you can use your own colors. Okay, that's all for the particles. I try to keep things simple, but if you want to improve them, use a texture on them, use a custom shader, animate them, please do. You can do it now by pausing the video. We are not going to change anything about the particles anymore, or you can do it after the lesson. That's great, but we are going to go even further by triggering a rotation when we arrive on the section. Okay, when I arrive on this one, the object will do a small spin. When I arrive here, small spin. When I arrive here, small spin. That's the idea, just to go even further. Okay, first we need to know when to trigger the animation. Follow me on that. It's not that related to 3GS, it's more like math and conditions and things like that. There are many ways of doing that. There are libraries, there are JavaScript APIs, observers, things like that. But instead, we are going to keep things simple and use the scroll Y value that we have here. And we are going to test that value. And from that value, we are going to know if we just change the section or not. So if we go there, the scroll Y value will tell us that we just changed the section. Okay, first we're going to add a new variable, which is going to be current section, and set it to 0, okay? Because by default we are at the top, and when we scroll, well, this variable will supposedly change to 1 and then to 0, 1, 2. We could have do 1, 2, 3, but you know, developers prefer to start at 0 because of array index and things like that. Then in the scroll event, so we're going to use the same one. You don't need to write another listener for this one. We can use the one we already wrote. We're going to do some calculation. So if you remember from the scroll Y, check that. If I scroll, as you can see, we get how many pixels are being scrolled. If I divide that value by sizes 8, check what we get. So sizes 8 is the size of the viewport. If I scroll down, so I have 0, 0, 0, 0. And when I reach the next session, like fully, I get 1. See that? I get 1. And if I go even further, and I get 2. And that's exactly what we want. Still, we want it to be triggered a bit earlier, like over there, so that we don't have to be fully on the section to see the animation. But that's the idea. Okay, cool. Let's create a variable. So const new section, and let's put that little calculation we did, a little formula. We can log it to see what's inside. It's the same. I just put it inside a variable. What we are going to do now is round the value. Why? Well, because if it's 0, well, we have 0. If we round that value, it's still 0, still 0, still 0. But when I reach 0.5 and above, it will be 1. Okay? So now it's going to be 0, 0, 0, 1, 1, 1, 1, because 1.31, well, if you round it, it's going to be 1, 1, 1, and 2. Okay? So let's do the math round on this whole value, and let's test it. So I have 0, 0, 0, 1, and I just reached that section. 1, 1, 1, 1, 2. And if I go back, 1, 2, 1, 0, and it's working. Be careful, this is working because each section is made to fit one viewport height. Okay, if you have sections longer than that, you will have to do a more complex setting. That's cool, but we don't want just to get the new section. We want to know when we change section. To do that, we are going to compare the new section to the current section. Those are just values. The current one is 0, and the new one seems to be, well, 0, 1, or 2. If it does change, so first we need to test that. New section is different to current section. We're going to save the new current section. So it's going to be current section equal new section. And we're going to simply log something. We can do changed and current section like that. Let's see what we get. So I'm at the top and I start scrolling. Nothing is being logged. But then I reaches this section, and as you can see, new section was different than current section. So the log showed up inside my logs, and I saved the new section as the current section, so that when I keep scrolling on this section, it's still 1, still 1, still 1, nothing happens. But then I reaches the 2, and tack, we get the log, and we save that the current section is 2. And if I go back, 1, 0, 1, 2, 1, 0, and it's working perfectly. Okay, great, we are almost done. What we need to do now is do the little spin on the objects, so animate the objects. Be careful, there is a small trick with that. We're going to use GSAP. All right, there are many ways of doing it, but let's use this library because it's working just fine. First, we need to add GSAP to the project. I'm going to get rid of the console log. I'm going to open my console. So you can open another console. You don't need to close the dev server already running in your terminal. Sorry, I say the console, it's terminal. But me, I'm going to close it because I don't have much room on the screen. And you're going to do npm install GSAP, and I recommend you to use the same version as me by adding at 3.5.1. Okay, maybe there are other versions since this one, but this way we are sure we are using the same one and the syntax will be the same. Okay, if you want to use the latest version of GSAP, please do, but the syntax might be a bit different. You press enter, it will add to your project dependencies. I'm going to restart the server. If you didn't stop the server, you don't need to do that. Don't mind the vulnerabilities warnings. I'm going to refresh and everything is still working. But now in my project, in the JavaScript, I can import GSAP from GSAP. I'm going to log it just to make sure that it's working. If I get something there, it's working. And GSAP, you can start using the different, methods and properties of GSAP. We're going to do a simple twin, okay? So let's go. Let's get back to our if statement, which were, there. So when we change the section, we're going to do a twin by doing GSAP 2, because this is how we do a twin. The first parameter is the object that is supposed to be to be animated. So in our case, it's going to be section meshes. Remember, it's the array containing every object, every meshes. And we are going not to choose the first one or the second one or the third one. We're going to use the current section 1, because remember, current section is going to be 0, 1, and 2. This way, it's automatic. And we are not going to animate the object, we are going to animate the rotation of the object. Okay, so rotation. If you want to make sure to understand this one, we can just log them. So if I log, let's say the array, I go up. So log, section, meshes, why it's not working, I don't know. So if I scroll, oh, it's not section meshes, it's section meshes. Oh yeah, sorry. Section meshes, singular. So if I scroll, see, this is my array containing the meshes. If I use the current section index inside that array, as you can see, we get a mesh. So that's actually the second one in the array. And we get another mesh, and another mesh, and another mesh. And then we want not to change a property on the mesh itself. We want to change a property on the rotation. So now it's the rotation, which is a Euler. Okay, cool. So let's get rid of this console. And we're going to do the animation. To do that, you provide, well, as the second parameter, an object. For the object, you need to provide a duration. So it's going to be, let's say, 1.5. You can provide other values like an easing, which will make well, the animation move at different speed, in, out, so it will start slowly and end slowly. That's great. And then we can change the rotation, and to just like add to the rotation, we can do X, not provide, I don't know, like 10, we can do plus equal 6. And for the Z, the Y, we can do plus equal 3. By doing that, it's going to add to the current value of the object. So if the object already rotated, which is the case, every objects are currently rotating, it will add to that rotation. We save. Be careful, it's not going to work as expected. If I do that, nothing. Seems to not be working, but I don't have any error. Thing is, if you check in your tick function, we are updating the rotation X and the rotation Y at every time. Like on each frame, we are changing the value and we just send one value. So even if we have those values that are supposed to twin, to be updated and things like that, in the end, we just put another value in it and it's not working. So we need to fix that. And there is actually a kind of easy way of doing that. Instead of putting a value in it, so assigning a value and just changing the value, we are going to add to the current rotation X, and we are going to use the delta time again, delta time, like that. And as you can see, it's still working because we are using the delta time that we calculated before. So it's the time between the current frame and the previous frame, and we add that after multiplying it to the rotation. So we get the same result. But now, if you scroll, we get the animation. The twin will change the value too. And we get something like that. And now our objects are being animated when we reach the section. Great. Let's go a little further and add the Z value. Z to add more chaos to the thing. Plus equal, let's say 1.5. We get kind of a cool result. Yeah. Looks a bit better because it's rotating in even more axes. Great. And that's all. We added many features. We added the parallax, we added particles, easing, we added a cool toon shader material, so it's cool. But you can go even further, all right? You can add more content to the HTML, okay? I just put some titles, but you can add projects, you can add links, you can add icons with, icons toward your Instagram, your LinkedIn, or whatever. You can animate other properties like the material. Yes, because we are just moving the object, but maybe we can play with the material properties. You can also animate the text. What I like to do is when we reach a section, the text animate, I like to do like a per letter animation, which is not what we are going to do now because it's a 3GS course. You can improve the particles too, because currently it's just squares. I think they look great, but you can do better and even animate them. You can add more tweak to the debug UI. We just have one color, but you can add much more. And obviously you can test other colors, etc., etc. And I will see you in the next lesson.